Now let's talk about copying and cloning the geometry. So as always, let's create a geometry node and let's dive inside the geometry node, and in here let's create a box, and that is the box that I want to copy and replicate. And to simply copy your geometry, we have a node called copy and transform. Let's add a copy and transform. That is a very simple node for copying our geometry. Let's add this. And onto the copy and transform, we have the number of copies. Let's increase the number of copies. Now all of these copies are on top of each other. So now let's add a translation into the Y to view the result. And let me keep adding this. Let's zoom out, and here as you can see we have this number of copies. We can adjust the translation into the X, and we can add the rotation value in here. Okay, and that's the very basic node of copying your geometry. And you can copy, right now I'm copying on the Y-axis. Let's zero it out. I can copy onto the X-axis as well as onto the Z-axis. Okay, now let's see how we can copy our geometry in radial fashion. And for that, let's create a circle node in here, and here we have this lovely circle. And to copy this, we have a node called copy to curve node. Let's add this because the polygon is the circle is actually a simple curve, so we can use this copy to curve node to copy our geometry onto circle. So we have this geometry to copy, that is my geometry to copy. And maybe let me duplicate this setup onto this side. And for this, let me create another box in here. Let's add a box and geometry to copy. That is the geometry that I want to copy, and that is the circle where I want to copy. Okay, so now we have these copies in radial fashion. I can adjust the radius by adjusting the circle radius. Let's adjust the circle uniform scale, as well as let's adjust the orientation. Right now we are on the XY plane. Let's change this to ZX plane. Okay, and we can adjust the number of copies by adjusting the number of subdivision on our circle. If I lower down the divisions, I'm creating less copies. By increasing, I can create more copies. Okay, and now we can also go back onto our original geometry, onto box, and in here I can adjust the size. Let's increase its size in this direction, or maybe into the Y direction. And I can also introduce some rotation to add an angle. Let's add an angle in here, and let's keep increasing, I think, Z size. Yes, that's the Z size. That's the size that I wanted to increase. Let's lower down its thickness a bit less. Okay, and let's lower down its height by changing the Y scale. And I can go into the circle. I can play around with the number of divisions, and I can now add a copy to transform node in here as well. Let's add a copy to transform, and let's copy all of this geometry in Y-axis. Let's create maybe 8 copies. Let's adjust its translation. Okay, so now we have some kind of rotor blade. I can add another rotation in here. Okay, and we can also introduce helix in here. Let's add helix, and let me duplicate all of my setup. Let's select, press and hold the Alt key and drag to duplicate this whole network. Let's select, let me rearrange this, and let's remove the circle, and let's put the helix in there. And for this we don't need the copy and transform. onto the helix. Let's change this one to logarithmic. Let's view the result. That is good. Let's go into the box. Maybe let's adjust its rotation. Let's change this to 45 degrees. And it's going in the up as well. Let's go into the helix and lower down its height so that we have these copies only onto the XY plane. That's the look that I was looking for. Let's go into the helix and let's increase the scale per turn as well as the overall radius, and maybe lower down the box size so that we don't have intersection. Let's increase the Y, but on the Z scale. And we can also go back onto the helix and lower down the number of copies by adjusting these subdivisions to create more or less of these copies. Let's increase them. Okay, now I can create another helix. Let's add this, and this time let's add another copy to curve node, and that is the geometry that I want to copy. Let's copy this onto another helix. Let's view the result. Okay, here you can see you can very quickly create some abstract shapes. Let's go into the helix. Let's increase its height as well as its radius scale, overall radius. I can also go back onto the copy to curve, and here we can introduce some rotation. Let's enable the additional rotation. Let's apply the roll. Let's increase the roll. Here as you can see, I can introduce some rolling effect. Let's also enable the yaw. Let's also enable the pitch as well. And let's introduce some pitch value to create a more interesting animation. Let me view my helix. And the helix is too small. Let's keep increasing this as well as its radius. Let's view the result once more, and maybe let's lower down the number of copies. We don't need that many copies. 5 copies is looking good, or maybe 6. Okay, let's go into the copy to curve and let's animate these parameters to create an interesting animation. We can add a $F expression, which means the current frame number. So let's add a $F, the current frame number, and let's hit play to view the result. Okay, I think the animation is looking slow, so let's multiply by this by 3 maybe to make our animation 3 times faster. Let's hit play. Okay, that's better. Let's also animate all of these parameters as well. Maybe let's add some partial twist in here. And to the yaw, let's add an $F. Sorry, not lowercase f, but uppercase F. And let's also multiply by this by 3. Let's go back and hit play. Okay, very nice. Let's also animate our pitch as well by adding the $F times 3. Let's hit play again. Okay, very nice, guys. And we can also animate this original copies as well onto the copy to curve. Let's go into the additional rotation. Let's enable apply roll, yaw, all of these rotation. Let's see what this does. Okay, let's add $F expression, $F times 3. Okay, onto the yaw as well, $F time 3. Okay, let's view the whole animation now together. Okay guys, that's looking very much interesting, although it's a very abstract shape, but it's a cool shape, cool animation. Okay, that's how you can copy your geometry onto the lines as well as path and curves, etc. Now let's see how we can copy multiple geometries by scattering some points. So for that, let's create a grid node in here. That is the basic grid where I want to randomly copy some geometry, and for that we need to scatter some point. We actually don't need to scatter some point, because if we enable the point display, here as you can see our grid has some points. If I create a box in here, or maybe sphere, and let's add a copy to points node, copy to points, and that is the geometry that I want to copy, and these are the points. I want to use these grid points to copy the sphere. So let's connect this and view the result. And now here as you can see, we are copying sphere where we have these grid points, which mean I can adjust the rows and column. Here we have these rows and column. I can create more or less copies. And if I want to randomly scatter some copies, I can add a scatter node in here. Let's add a scatter node. Scatter node will scatter some points onto the surface of the input geometry. Now let's view the result. And the scatter point is too much. We can lower down the number of scattered points. Let's lower them down. Okay. And let's add a box in here. Box. Let's connect this. Now we are copying box onto this grid and onto these scattered points. And if we want to copy multiple geometries, let's say I want to copy box as well as sphere as well. Let's see how we can do that. And for that, first let me remove this and let's create another setup in here. And for this one, I am copying all of this setup. Let's select all of them and let's drag this to duplicate all of this setup. Okay, so these are the box. Now let's introduce some more geometry into these copies, and let's create a platonic in here. First platonic, sorry, what's I'm typing, platonic, that is our platonic. And maybe let's create a sphere as well. Primitive sphere has only one single point, which is fast for copying. So let's use the primitive sphere this time. Let's add an merge node in here to merge all of these geometries together. Let's connect them. And if we view the result, here as you can see, all of these geometries has been copying. And if we view, here as you can see, all of these geometries are on top of each other, and copy to point node thinks that all of this is a single piece of geometry, and it is taking all of these input geometries and copying them onto these points. Let's tell copy to point node that we have these different types of geometries and we want to copy them separately onto these points. Okay, and for that we need to create an attribute on both of the side. We need the attribute on the geometry side as well as onto these point side as well. And for that we have a node called pieces node will transfer the attribute. So it has two inputs, the point cloud, that is the point cloud, and it needs the geometry library, and that is our geometry library. And this node will transfer the name attribute from the geometry library to these points. Okay, and right now we do not have a name attribute, so let's create one. And for that we can use an assemble node, And let's connect this. The assemble node will generate name attribute for us if we middle mouse button. Here as you can see, we have a primitive name attribute and it has 3 unique values, and that is because the assemble node is looking for the connectivity of these objects. If we view the box, it is a one connected piece of geometry, platonic is another, and sphere is another. So the assemble node is looking for the connectivity and it's assigning the name onto each of these connected geometry. So we have these 3 names, so which means that we can connect this node in here. Okay, and now the attribute from pieces node will take this name attribute from the geometry library and transfer them onto these scattered points. If I middle mouse button, here I don't have a name attribute. When I connected the attribute from pieces node, if I middle mouse button, now we do have name attribute and we have 3 unique values. So which means I can connect this node where we have the name attribute present, and we also need to connect this assemble node where we have the name attribute present, okay, on both of the side. Now we need to tell the copy to point node to use these name attribute to vary our geometry. So let's go into the copy to point node. Nothing has changed. Let's bring up its parameter, and in here we need to enable the piece attribute. So let's enable this. As soon as I enable this, here as you can see, now we are copying all of our geometry. Let's go into the sphere. Let's adjust its uniform scale down. Let's adjust the platonic scale down as well as box scale down. And maybe I can make the grid size, overall grid size, a bit bigger. And now I can generate more of these points to create more copies. Okay, and onto the attribute from pieces node, we have the option mode for transferring these attributes. Right now we are cycling. I can change this to patches. Now I can define the patch size. For example, if I make patch size smaller or bigger, here as you can see we have a pattern of copying. Okay, I can also change this to noise. So now we are using the simplex noise, and we are using the noise based distribution of our geometry. Okay, let's keep this to cycle. Okay, that's how you can copy multiple geometries. And now let's take a look at the scatter and align node. Let's add a scatter and align. So the scatter and align node is the same as the scatter node, but it has some few parameters, so it's a bit more advanced than the simple scatter node. And by using the scatter and align, we can also align our geometry. Okay, so let's see how we can do that. And for that, I'm going to, I think, copy this setup, or maybe let's create another one. Let's add a grid node in here. Let's connect this. Let's go in here, and now we are using the grid to scatter some points, and the scattering method, let's go into the scatter parameter. We have lot less points. That is because we have a point count method by size. Let's change this to number of points. Now I can manually define how many points I want. Okay, and here we have the coverage area. Let's keep this to all the way up to 1. We want to use all of the surface of the grid to scatter the point. Okay, and if we take a look at the simple scatter node, we should have the same distribution of the points. Let's enable that. And here as you can see, we have a little bit of difference, and that is because if we go into the scatter and align, we have a global seed which is set to a random value. And if we take a look at the simple scatter node, it has a global seed value of 0. If I change this one to 0, let's change this to 0, and now I should have an same distribution of points. Okay, that is an same distribution. Okay, so far so good. Now let's see how we can orient copies. And to check the orientation, I'm going to create a box, and let's add a copy to points node in here, and that is the geometry that I want to copy, and that is, these are our points. And let's see, now it's looking same, but this scatter and align node is generating some few attributes for us. If I middle mouse button, here as you can see, I have N for normal, and we have the orient, which is used to orient these copies, as well as it's generating the p scale attribute to set the scale. And we don't need to generate the p scale, so let's go into the attributes, and here as you can see, we are generating the radius attribute. So let's uncheck this. Now we are not using the p scale attribute, we are only using the orient for orientation. Now I can use the uniform scale value in here to scale my copies. Okay, and I can go into the scatter and align and onto the orientation. Here I can adjust the orientation. I can rotate my geometries around the normal by adding the offset angle. Here as you can see, I am rotating my copies, and if I can adjust the min and max angle, I can randomly add rotation onto my copies. I can also adjust the random cone angle to adjust the axis. Okay, that's a very useful node for scattering and aligning our geometry.